Thanks for the intro. All right, so appreciate everyone joining me on Friday afternoon. I will say up front, I thought my talk was 45 minutes. It's an hour. So if you guys want to interrupt me as I'm going, I'm going to try to slow down and feel, it's a small crowd, so I think we can talk through things if you'd like. So kind of a corny title, but we're going to spend some time today talking about data privacy, privacy of your subjects, and machine learning, and how they can be in conflict with each other, and some workarounds that maybe you can use to meet the obligations of your data subjects, yet still do the machine learning initiatives that you want to accomplish. So I'll spend a little time talking about historical anonymization techniques and their failures and things you should be concerned about. And then we'll talk about some strategies you can use to avoid these problems. And we're going to get into a couple of legal things as well, such as GDPR. Okay. So I'm going to come back to this quote several times during the talk. So this is a great article in the UCLA Law Review by Paul Ohm. If you guys have the time, I highly suggest reading it. It was written in 2010, but still applies today. Data can either be useful or perfectly anonymous, but never both. I'm going to spend a little bit of time in the slides attempting to disprove this to a certain extent. But as I mentioned, we'll keep coming back to this. So first we'll have a little fun. So everyone loves breaking privacy. We're going to break Judd Apatow's and Leslie Mann's privacy today. So this is a picture of them enjoying a ride in a New York taxi cab. And I know stuff about Judd Apatow and Leslie Mann. So we're going to get into what we know. So there was a FOIA request. Someone made a FOIA request. If you guys know what that is, it's like an official way to extract data from the government. So someone made a FOIA request for all the New York taxi data. Some of you may be familiar with this. It's a great data set to play with and use. It's massive, millions and millions of records. It's every single taxi pickup and drop-off trip. I think it goes back like 7 years now. And the data looks pretty harmless, right? You wouldn't think this is personally identifiable information. It's the taxi medallion, where they picked up the individual, the time of the pickup, the fare amount, and the tip amount. So, but it actually is not harmless. So as you can see in this picture, we have the taxi medallion here, H8G12. So what you can do, this photo is geotagged with time, so we can understand where the pickup occurred and the taxi medallion, so we can go into the data and link it to the data. Okay, great. So now out of millions and millions of rows, we found Judd and Leslie's taxi ride. But why this is funny, interesting, I don't know, is that we can also know what they tipped the driver on a $9.60 fare. So actually, Gawker ran this on a bunch of celebrities. I picked this picture because it was the funnest picture, but there was a bunch of other celebrities that had zero tip amounts. And the theory was if you paid cash, the taxi driver didn't report the tips. So I guess the cab drivers aren't paying their taxes or whatever it is. But so that was like the theme behind the tabloid fodder. So this was a fun but good illustration of how you can break privacy fairly easy in data. So we'll dive a little bit more into this. So this is an example of a link attack where you have some existing data that you've maybe been provided or an adversary knows about, and then some new data they bring into the picture in order to break privacy. And so in this case, we had the medallion and photo time, and we were able to link it to the taxi data to break privacy. Going on a short tangent here, New York actually tried to do the right thing and anonymize the medallions, and the way they did that was through a hash, but they didn't salt the hash. So getting in a little technical minutia, there's only so many combinations of taxi medallions, so someone just built a rainbow table and reversed all the hashes. But what I'm going to tell you is, even if you couldn't reverse their hash, it still wouldn't have done any good, because so let's say, so they did hash the medallion, so that breaks this attack. But I could do a different attack where if I knew the pickup time and location, like I crop this picture's cropped, you can actually see where they are. So you could still do this link attack. So maybe we'd hash the pickup time. Well, okay, what if I knew the pickup location and the drop-off location? Well, New York Taxi could hash the pickup location. Well, what if I knew the drop-off location and time? And you kind of see where this is going. I'm having to hide all the data to make it completely useless just so I can protect the privacy of the individuals. And this last one is just, hey, what if I hopped in the cab after them so I knew the time and had their receipt? So we could link it that way. So we're coming back to Ohm's quote here. We made it perfectly anonymous but completely useless, right, by doing that. And what it really boils down to is you can't really provide guarantees of privacy or define privacy because you don't know how much the adversary knows external of your data. So really the cardinality is the Achilles heel of anonymization. So if you think about all those things I was just masking, the pickup location, the times, those are columns that contain a ton of unique values. And those unique values provide you the hooks to do these link attacks from external data sources. So those are called quasi-identifiers. And quasi-identifiers aren't personal data, but what they are the keys to the kingdom to the personal data. And in fact, they're typically the things that are most interesting for you to analyze because there's so many unique values in them. Like what good is aggregate statistics on a gender column, right? So I'll run through a couple other old techniques to tackle this problem that don't work either very well. So there's this thing called k-anonymization. So k-anonymization is a way to mask the quasi-identifiers in a way that makes them useful. So you can think of this as grouping them together. So you can see my examples down here. I chopped off the last 2 digits of the zip code or rounded the age and the coordinates. So this provides some utility in those quasi-identifiers to do analysis, yet still potentially protects the privacy of the individual because there's less to hook onto for a link attack. So this is an example of a k-anonymized data source where we rounded the zip code. Does anyone notice an issue with this? Give you a second to look at it. If we were trying to protect the problem, if we didn't want people to know what the problem was. So if I told you I was a white male born in 1967, would you know what my problem is? Yes, because that's called a homogeneity attack. So even though we chopped the zip code, and in this case we had a K of 2, both people had chest pain. So, oh, that's what I forgot to mention. So you try to make the grouping, the K stands for how many unique rows you want in each group to try to protect like things like a homogeneity attack. And there's another one in here. Black females born in 1965 have hypertension, the 2 black females there. So just to show, there's certainly more utility in this. If we hash the coordinates, you wouldn't even be able to like do any kind of spatial analysis, right? So this is zoomed out. We can still do broad general statistics on this. But as you zoom in, you can see we get more of like a pepperoni pizza look on the right there of the, because we've grouped those coordinates together. So we end up with similar challenges though, because if I had a very unique pickup and drop off location, then I could still, even though I've grouped those into K amount of groups, that's still probably a unique enough trip that I'd still be able to find that row in the data. Or I'm probably exaggerating on this one, but what if everyone in that trip location and time span did the same tip amount? You'd still know the tip amount then, just like we knew that they had chest pain. Okay, so I just think this is funny and I like to get other people in on the joke. So my director of data science went to the Big Ten tournament, if you guys know what that is, the basketball tournament, college basketball tournament. And before the game, they k-anonymized the players. See, everyone's Potter on Ohio State and Johnson on Rutgers. Obviously, this is just like the way they were setting up the scoreboard. They weren't really k-anonymizing the players, but now it's not just a joke between me and Jim. But But the thing is, though, you can see how this would easily be broken, right? As soon as one of the players scores a basket, you would know which one they are in the data because you just saw it happen. So you, as the adversary, have information that you can link to the scoreboard to break privacy. All right, so just to keep you guys awake, we'll play a little game here. So the privacy versus utility game, I use the classic Billy Madison as an example here, my favorite. So we're trying to hide the movie title. That's the private data that we're trying to protect. And I've circled all the quasi-identifiers in purple here. So things we're going to try to mask. So the first one is pretty simple. We basically did what New York Taxi did, which was just mask the medallion. In this case, I masked the title. So anyone know what this is? Yes. I first gave this talk in UK. That's why I picked this one. Okay. And then this one, we spiced it up a little bit with some k-anonymization. So you can see I chopped off the last digit of the year. So we've rounded to decade. I made the runtime 3 hours instead of what it really was and removed the description. But I'm guessing you guys know what this is based on the stars that are in it, right? Yes. And one thing I wanted to point out, I left that chopped year off there because you notice the year is written twice on the screen. And so if you do k-anonymization on one column and there's one highly correlated, you need to make sure you do it on both. So just another challenge with doing that. And then here's my favorite. This is the perfectly anonymous but completely useless movie. I think, so maybe you could figure out average rating by decade. I don't know how useful that is, but obviously no one's going to be able to guess this one, but this is Terminator. And there we go. Ohm is back again. So bringing this back to a real example. So there's this guy, Yves Alexandre de Montoyer. He's a researcher out in the UK, and he did this awesome study where he took credit card transaction data. So imagine the credit card transaction data is going to look a lot like the taxi pickup and drop off, except there's no drop off. It's every transaction you make with the location and time. So what he did was he took all that credit card transaction data that was theoretically anonymized, and he looked at Instagram photos and like tweets about having coffee or the phone you just bought, and he was able to take that and link it to the credit card transactions, and he was actually able to mathematically prove that you only need 3 unique points in order to find the unique person 94% of the time. So in other words, if we had 3 pictures of you getting in a cab at 3 different places, with 94% chance we could find you in that taxi data. So that's kind of crazy, right? So just think about that. So a couple tweets or Instagram posts, and the reason it's possible is because there's more data than ever now that you can link to other data. And back in the 80s and early 90s, these techniques like k-anonymization worked. I mean, I would even argue HIPAA is just as breakable as the taxi example we just went through. So it's because there's just so much more data out there. This is an easy thing to accomplish. And the point is, it's very easy to build profiles of individuals. And this is why everyone is interested in Facebook's data, as you saw on the news. And so, how many people have heard of GDPR? Okay, good, that's a lot of you. So if I would ask that question a year ago, how many people would have heard of it? Yeah, not that many. So it starts in May, and it's not just a slap on a wrist, finds up to 4% of your global revenue. So that's a lot if you're like an Apple or a Facebook, right? And I'm not going to read this whole thing to you, but I want to point out the one part which says it relates to any identifiable natural person is one who can be identified directly or indirectly. So GDPR applies to any EU citizen data. So if you're in a US company and you have EU citizens in your database, GDPR applies to you. More indirectly, and I'm splitting hairs here and this is not realistic, but in a sense, there's probably EU citizens getting in New York taxi cabs. So in fact, New York Taxi could be breaking GDPR, right? Because I could indirectly identify individuals in their data. So what GDPR is really worried about, though, is I think some of you probably saw the keynote. Her name's escaping me now. Yeah. So you saw her keynote about the dangers of making automated decisions. Well, that's really what GDPR is worried about, and the privacy behind that. And so this isn't just GDPR. There's these regulations growing all over the globe. So China's new cybersecurity law is based after the GDPR. I found this article. The New York City Council was debating whether they should share the source code of all their algorithms. And you can imagine if you have data across the globe that you're using and you have to deal with all these regulations, that becomes crazy very quickly. So I don't want to depress you guys too much. So that's kind of the why this is important. So now we're going to dive into why I actually think it's a good thing. So at the end of the day, data privacy is just one part of the risk that your organization takes on by making automated decisions. And I'm sure you guys deal with this all the time. Risk is what slows you down in deploying production models. And if you can manage your risk and bake in these controls up front, then it's going to accelerate everything you do in your organization in terms of machine learning. So I would argue, I'm going to give you some best practices here in a little bit, that these would actually make things better for you. So we're going to run through these 3 bullets. So we're going to talk about using the customer data beyond the scope of what they expect. We're going to talk about using only the data necessary, and we're going to talk a little bit about understanding what's actually visibility into what's going into your models and how you're training your models. So this first one, I'm just going to take us on a little trip in time here. So back when cameras looked like this, it was really expensive and hard to get your picture taken, obviously. But then this fancy new gadget came along where anyone could take a picture at the turn of the century, and that freaked people out. So you can see this quote. This is from Louis Brandeis, who's a U.S. Supreme Court Justice. Instantaneous photographs in newspaper enterprise have invaded the sacred precincts of private and domestic life. What they were worried about is their picture showing up in the newspaper the next day. And that sounds crazy to us now, but back then, that was an invasion of privacy. And they proposed a bunch of rights to be let alone, and this led to some of our privacy laws that we have today. So today, we generally accept being observed, but we rarely accept being identified. So my colleague, Andrew Burt, he wrote this op-ed for New York Times. Again, something I recommend reading. It's a quick read, but in summary, the theme of the article is the rise of technology and data science has killed privacy as we know it. If you think about it, basically the toothpaste is out of the tube. It's not getting back in there. Data collection is not going to stop. So instead of focusing on how your data is getting collected, the future of privacy enforcement is going to be how your data is being used and consent. And so the GDPR understands this. This is the cornerstone of the GDPR is consent. So you really should only be processing data for the purposes that your data subjects have explicitly consented. So put another way, think about the analytical context of what you're doing and if that data can be used for that context or not. And I threw this last bullet in here just as something to think about. I mean, most of us think about access to data or rows of columns of data as role-based or attribute-based access. Purpose is different for really 2 reasons. Someone's purpose can change many times throughout the day, right? You're not going to, like a role and an attribute is usually something maintained in like LDAP or Active Directory. You could work on a different analytical goal, 3 times during the day. So that's a challenge of it. The other thing is if you belong to 6 roles and all 6 of those roles are allowed to see data source A, how do you then audit the fact of what purposes you're touching that data for? So that's another key point in the GDPR is that you need to prove what you're using data for so the GDPR police can come knocking on your door and say, hey, there's not GDPR police, but the auditors can come knocking on your door and say, hey, show me every purpose you've used this data for, and you should be able to answer that question. What's that? Oh. So bottom line, you should start thinking about this and doing it if you can. All right, so this next section is, I think this will be the most interesting piece for you guys, because I'm sure there's a lot of very technical people in the room. So are you only using the data necessary to make a decision? So I'm giving you more homework. So there's this internal study that Uber did, another good read, where they analyzed all the SQL queries written by all their employees from 2013 to 2016. And this was things like their rider and driver information, their trip logs, their customer support stuff. And there's a point to me showing you this. I'll get to the point here in a second. But I want to point out 34% of the queries were statistical. So that means they were aggregate questions like sum, min, max, median. And then the other raw queries were like individual rows of the data. So 34% of Uber data science queries are aggregates. So statistical queries matter. So if statistical queries matter, I was actually surprised at how high that number was, then I can actually convince you that this might be a lie in some cases. So our own quote that we've been going back to many times. So how do we do that? So I'm going to play another game with you guys. So I play this. I've done this talk a few times. Every time I play this game, no one plays. So play the game. I'm not going to break your privacy, I promise. So think of a number between 1 and 6. Don't say it. Just think it. And then I'm going to ask you a question you don't want to answer in public. Don't answer it. Just think it. Do you hide spending from your spouse or your girlfriend, boyfriend, your dog, whatever? Now, if you picked a 3 in your head or you answered yes to hiding spending, raise your hand. That's more hands than usual. So the people that raise their hand can certainly just say, hey, I picked a 3, right? So I gave you plausible deniability. So that's what differential privacy is. So we added noise to the response so that we could protect everyone's privacy. But the problem is, or not the problem, the goodness is that I can actually figure out how many people hide spending from their spouse because I know what the probability of you selecting a 3 was. So I'll talk a little bit more about this next bullet, but it's only restricted to statistical queries, which is why that Uber study is important, right? If you're asking statistical questions 34% of the time, then differential privacy can provide you guarantees of anonymity and give you some utility out of your data. And this quote from Frank McSherry, he's a great read too. So he's kind of like a famous touter of differential privacy, and he provides that formal description of what differential privacy is. So there's a catch to differential privacy. Of course, nothing in life is free. So you can only ask aggregate questions, which we talked about. The other issue is that if you ask the same or similar question enough times in a row, you can kind of beat down the noise and figure out the real answer. I'll show you this in a second. And then the idea of sensitivity is very challenging to assign. So what I mean by that is, let's say instead of asking you guys if you hide spending from your spouse, I said, are you wearing pink shoes? And there was only one person in the room wearing pink shoes. That question was very sensitive, so we'd have to add a lot more noise by telling everyone to pick a 1 or a 2 or something, instead of picking 1 out of 6. So if you think about it, it'd be really hard on a database to understand how sensitive a question was. So back on that privacy budget, if we went back to our movie game, let's pretend that we were trying to protect the rating instead of the movie name. So this actually describes another small issue with differential privacy is you can't really ask questions that respond in a string, obviously, if you're doing aggregate queries. So if I ask that same question 4 times in a row, I can start getting the average based on the noisy response and get to the real rating, which I think was 8 or something. So I wanted to talk about like how could New York Taxi have done it actually with differential privacy. And this is one of the things my company does. We provide a differential privacy layer on your data. So what happens is, what you could do is you could expose a query layer to the users that want to hit that taxi data, and that query layer can push down that query instead of querying the data directly. There's a technique called sample aggregate, which essentially you break that query up into a bunch of samples and run them independently of each other. And then based on how closely those responses are to each other, you know how sensitive the question was. So again, if I ask that question, where medallion equals this and pickup time equals that, only one of those samples are going to respond, right? So I know that's a highly sensitive query. And in fact, what we do is we just block it instead of adding a lot of noise and say, hey, you asked a query that's too sensitive. And then to get by the other things, we'll actually cache those noisy responses in a fuzzy way. So you keep getting the same noisy response back, and you can't break down the statistics. And you can set how long that cache lasts based on how often new data is arriving. So you're kind of buying back privacy budget by new data arriving in your layer. And then obviously the query layer would restrict to only aggregates. So what about machine learning? So we've kind of been focused on the internal use of data or external use of data, but there's actually ways to do attacks against machine learning models too. So for example, there's a lot of public-facing models that you can use on like Google Cloud, for example, and Microsoft Azure. And these kinds of attacks are similar, so we can do something called a membership attack. So this is trying to determine if someone was used in the training of the data, and you can kind of see, I wrote the quote there, how it works, but it's basically you have two competing models and comparing their results, so you can figure out if someone was in the training set or not. But more interestingly, there's a way to extract training data as well. So I haven't read, so you can see that thing I highlighted. They were able to figure out if a respondent in a lifestyle survey admitted to cheating on their significant other. That was my original differential privacy game, and I was like, no one raises their hand on that one, even. I think I haven't read it in a while, but the way it works is they basically replace a feature vector, like a value in a feature vector, with a bunch of different values, and then decide which one was the most likely, and you can kind of rebuild the training data that way. So how can we use differential privacy to protect our production models from these kinds of attacks? So there's this awesome blog that this guy, Nicholas Papernow and Ian Goodfellow wrote. So Nicholas Papernow, we work with him. He's a great guy. There's actually a scholarly paper that backs up this blog, but I would definitely read this blog. So they have this thing called private aggregation of teacher ensembles, so PATE, which is a great name. So the way this works, so this picture, it looks a heck of a lot similar to this picture, right? So what happens is, instead of sampling your data like we were doing with the SQL queries, we're now using an ensemble of models that we built. These are called the teacher models. So you can have each one of those models have to be trained on exclusive data, so no data can exist in more of one of the ensembles. And what happens is, then you can ask the ensemble a question, and then based on their responses, it will add a little bit of noise based on, like if they were all healthy and one cancer, there'd be very little noise, but if they were split down the middle, like this example, there would be a lot of noise. And in fact, what they do with PATE is, if there's a big split, they just don't let it respond at all, kind of like I just told you about with the SQL thing. It was a too sensitive question. So what you can do with this is then you can lay another model behind it and train it based on the ensemble's responses. So now you have a student model from the teacher ensemble that is completely private, and you can't do those attacks I just described. That's pretty cool, right? So what's the point? So you should protect your data subjects always. So really, it's a bad idea to just have a data free-for-all in your organization. If you got everyone's personal data sitting on your Hadoop cluster and everyone's just going to town, you really should think about some of the things we talked about, and then also consider attacks on your externally facing models as well. So we discussed some techniques here, the purpose restrictions, and being able to do the masking and row-level security. In fact, GDPR calls this privacy by design. So as we discussed, the hashing and the k-anonymization, while they're not foolproof, they still provide, unless someone's really trying to be adversarial, you're still at least hiding the personal information. And so you owe it to your customers and yourself. We don't want to be in front of Congress, right? So the last thing I'll talk about, am I like way under time or how are we doing here? Yeah, I'm way under. Okay. So do you actually understand what data was used to train your production models? All right. So how many of you guys have production models running right now? Okay. And of you guys, does anyone know in the organization all the data that went into them? Okay, we got 1 out of 10 or so. So I'm going a little off topic from privacy, but again, as I mentioned, privacy is tied to risk. And I think this all kind of blends together when you think about the risk involved in your machine learning models. So there's this thing called SR 11-7. So it was written by the Federal Reserve, and it provides general guidance on managing risk with machine learning models. And it's really targeted for the financial industry, but I believe it is relevant to anyone doing machine learning and trying to manage risk around that. So there's 2 major risks: model errors, which is the one we always think about and are trying to fix, right? And then, but there's also the misuse of models and making and understanding, the data that went into them and trying to represent reality in a meaningful way. You can really think of it breaking down the risk into 3 layers. What I'm talking about today is more highly correlated to the input layer here, where regulating the data itself. So are you accurately representing your users? I didn't really talk about quality, but that's something else you should be considering. Are you appropriately using the data? So relevant. So this is the consent stuff that we talked about. So are you using it the way the user consented, but also is it relevant to the job that you're actually trying to do? Are you using appropriate legal proxies? So yeah, you shouldn't be using race, but does that mean you shouldn't be using zip code? You should think about those things. And how do you handle changes in policy and data for these existing models? So I think this is a really important one. So once you put a model in production, then what happens? So you should really understand the data that went into it, because if there's a policy change around the data, then maybe you need to pull some of those models back and retrain them without it. If, or you stop getting some data feed that feeds a model. Like, how do you know like where those all exist? So I call this ML bookkeeping. I'll talk a little bit about that on the next slide, I think. And then there's the model level, which is the interpretability versus accuracy trade-off. Again, this isn't relevant to this talk, but things you should be considering. And the output level, which is measuring or monitoring your output and your conclusions and back testing and all that good stuff. But really, the input level is you've got to have visibility into what's going on, what user data is going into what models to train what and for what purpose. So just to recap, I guess I didn't talk about that in the next slide, is understand and capture consent when possible and have mechanisms to enforce those purpose controls for usage. Avoid data free-for-alls. So not everyone should see everything. And there's always going to be that utility versus anonymization trade-off. But I'd argue the risk of not doing that outweighs the reward of ignoring it. And think about differential privacy at your organization and leveraging that. And then just what we just spoke about, what I call machine learning bookkeeping. And another good read is this thing down here, Hidden Technical Debt in Machine Learning Systems. Change anything, changes everything. So you can think of it as a house of cards. And you just need to understand everything that's going on in terms of what fed the training of your models to what's feeding them in production and all that stuff. So that's me. Work for Immuta. I actually have. I wasn't going to show this, but since we're under, I will. I have a little movie of differential privacy in action. So this is a query. So this is a query I'm going to run against some insurance customer data where I'm selecting the average income, where the education level is bachelor, and you can see the response is actually slightly off from the original response of 37,426. So that's that noise being added. So the response we gave back was 37,580. And then we're going to ask this next question where the same question, average income, but where education is master's degree and gender is female. And you can see there's slightly more noise added. Sorry, you probably can't see this, but there's slightly more noise added in this one because it was a more sensitive question, a more specific question. And then we asked this very specific question where the user or the insurance customer lives in Arizona and their monthly premium is exactly $132. So this is a very sensitive question, probably an adversary trying to break privacy. And you can see we get this, your query is too specific. You have to ask a more broad, general, aggregate question. All right, so that's it. Sorry, it was a little short. Are there questions?
Yeah.
Can you speak to the differential privacy that Apple is supposed to be using on iOS?
A little bit. I mean, I've only read the same thing that you guys have, but yeah, they do it at collection time, so it's a little bit different than what I was talking about. So basically, they add noise when the data is getting collected, and then kind of beat it. They know how to beat it out because they know how many. Like they know that there was 6 sides of the dice when they added noise, which is a little bit different than what I was saying, which is interactively applying it at query time based on the sensitivity of the query.
And as an unrelated follow-up, what kind of systems does Immuta apply their system to?
So differential privacy is anything relational, any database we can slap it on top of.
Thank you.
Mm-hmm.
Thank you. My question is kind of on the, not so much on the how, but how do you get stakeholders to get to a commitment to do this? I'm presuming that in kind of a sales cycle for Immuta that you understand kind of what are some of the motivators, but most often what we see is blunder funding, right? Where, you know, you wait till something horrible happens and then, oh, we should spend money preventing that from happening again.
Yeah, I think, well, obviously most of our customers are very large customers that have compliance and legal departments. So what typically happens is they're beginning a data science initiative and they have to basically get approval from legal and compliance. And with all these new regulations and policies that exist, and I would argue, you know, today is a lot different than 3 years ago because data scientists need an unprecedented access to data. It's not like an analyst visiting an app and clicking buttons anymore. It's, you've got 50 data silos. How do you enable access to 50 data silos in a frictionless way? So that opens the door to a lot of compliance challenges. And so IT goes, oh crap, how are we going to do this? And so it's basically a collaboration between the data scientists need to do their job, the IT folks don't know how to enable them because of the pressures from compliance. So those 3 forces coming together kind of drive adoption.
Thanks.
Yeah.
Hey, this was a great talk. I am definitely left feeling like I'm on eggshells with data. I mean, I'm not personally working with tons of data, but It does seem like there's so many avenues to break any anonymity that you have on the data. And I wonder, you know, it seems like there's ways to try to reduce some of the risk that you've talked about. But I wonder if any of this parallels the kind of work that's gone into like securing systems in general, where rather than say we're going to make an impenetrable wall that you can't break our firewall or whatever, and then everything on the inside is vulnerable. Yeah, I know Google has like their Beyond Corp and everything like that. Is there any way that any kind of research or any kind of policy work or anything that you're familiar with where rather than just being a preventative approach is also kind of a way to handle things when they go wrong, when things become de-anonymized and I mean, I guess once it's out there, right?
Yeah, I mean, so something to think about. I didn't really say this when I was, let me scroll back to this slide. So when people think about sharing data, the first thing they think of is copy, export, hand off. And you don't need to do it that way. If you provide an interactive way to query the data where you can monitor what people are doing, obviously they could do a select star and then go run off with it. But you can at least monitor what people are doing with the data. So I don't know if that completely addresses your question. I mean, security and data privacy, they certainly overlap, because if you have a breach, you obviously break everyone's privacy. But potentially, I mean, if you're putting these barriers in place, maybe the breach happens behind your data privacy protections and it's not as bad. But data privacy is more about what we've been talking about, that quote. Like, how do you provide utility yet still protect privacy? So it's a little bit more of a gray area than security, the way we think of security. So I don't think if someone breaches the data, and you have some of this enforced, the only thing stopping them is not being able to find an external thing to link it with. I mean, you're kind of lost at that point. Yeah.
Hi, I have two questions. My first question, could I get your thoughts on the right to be forgotten and what, like, kind of how you're thinking about it and how your company is thinking about it?
Sure. So for those who don't know, the right to be forgotten is another thing in the GDPR where essentially a customer can come to you and say, I want you to forget me. Long story short. So you have to delete every record of them. So we Immuto don't actually try to address that problem. That's more of like an entity discovery problem where you'd have to go and delete that user. One thing to think about, though, is if you train your model from that user's data, you then have to retrain it. So I'm going to botch this, but that Andrew Burke guy I referenced, he's a Yale-trained lawyer, and he's put a lot of thought into this. And I think his reading of that is that, no, you don't have to do that, because you're not using the person's data, you're using an output of their data. But I'm not here to provide legal guidance, and I could be botching what he said, but bottom line, I think that's up for legal interpretation on the do you have to retrain your model or not? Do you have to delete the person's data? Certainly. And how you keep track of whose data is where is a big problem that we don't necessarily try to solve.
And so my second question is, so I recently learned about like multi-party computation with regards to like encryption scenarios, and are there sort of versions that you apply that to within the machine learning space?
So is that kind of like the homomorphic encryption stuff?
Yeah.
Yeah, so a lot of times people confuse homomorphic encryption with data privacy techniques. Homomorphic encryption is still black and white, right? You can ask the question of the data, and it's going to give you an answer. You're either allowed to ask it or you aren't. The only thing it's protecting is that no one can see the question that the question going in and what's coming back. So that's really more of like an internal measure to make sure like the database admins aren't watching what everyone's doing.
I have a question about, as you said, right, like a lot of projects are project-based. Not everyone should have access to the data. So what happened with my company is we're just too big and I work across different teams. I find a lot of people do the similar things. But there's potentially with transfer learning, right, there are common models that people can use build on that. But because of the very strict control, like every team to do their own. Like product team, they might develop their own models, but actually the research team already developed. How do you think this can good control, but also can build knowledge assets, can like utilize across the organization when it's just too big?
Yeah, I mean, I don't want this to be like a Immuto advertisement, but that's one of the things we think about is like actually, trying to centralize the access layer so that you understand everything everyone's doing across the organization. So if you can centralize your controls, then you can understand who's doing what and what's going where.
So it's like an add-on on one platform, right?
Yeah, we would just like slap ourselves across your databases, basically.
You talked a little bit about auditing, and I wondered if you could expand a little bit on your ML bookkeeping idea.
Yeah, so what we're thinking about is, so think about it this way. If you could tell everything everyone was using for all their models, you know what features went into what models, then you could start to do things like monitor for drifts. You could say, hey, those 6 features you use, they look a lot different 6 months from now than they did, or they look a lot different now than they did 6 months ago. You might want to like go back and look at what you're doing. So things like that. I think if you really have a good understanding of what data went in, then it's really easy to make decisions on things. Or like I said, if a policy changed, you can say, these are all the models that I need to go look at that are out there already.
Are there any tools out there already that can manage this or keep track of this?
Not that I'm aware of. That's why we're doing it.
Thanks.
Yeah. Okay. Thanks, everybody.
Okay. Thank you, ladies and gentlemen.